So hi, I'm Anwesha Roy.
Hi.
Yes.
Hi, I'm Melanjaran.
Hello, I'm Omkar.
Hi, I'm Priyanka.
Hello everyone, I'm Sayantani. I welcome you all to this event on behalf of the Curry Leaf team. Today we are lucky to have amongst us Professor Ananthnarayan Hariharan. He is currently a faculty at IIT Bombay. He completed his master's from IIT Bombay and received his PhD from University of Kansas, USA. His research interests include commutative algebra and homological algebra. He also happens to be an MTTS alumnus, and he attended the MTTS camps of 1998, 1999, and 2000. Apart from that, he is also related to MTTS as a faculty of MTTS. Thank you so much, sir, for giving us your time. And today we will be taking an insight into Professor Ananthnarayan's mathematical journey and ask him a few questions. Thank you.
Sir, are you ready?
Yes. Am I supposed to answer all of them?
If you want, then yes.
Okay.
Okay. So can you tell us a little bit about your background and what influenced you to start a career in mathematics?
I was not good in anything else. Well, I mean, that's actually quite true. So at every opportunity I got, I started dropping other subjects and eventually left with mathematics. But no, I mean, that's partly true, but partly I think I already had a flavor for mathematics because my maternal grandfather was a mathematics school teacher. I mean, he taught standard 10th, I think, for quite some time, and was a very well-known teacher in Madurai. I mean, and so that was always an inspiration, kind of at the back of my mind. Like it's grandfather was a mathematics teacher. I would like to be a mathematics teacher, kind of a thing. So, and as I said, of course, pretty soon I learned that it came slightly more naturally to me than other subjects. And very quickly I learned that when I was in 11th and 12th, I learned that engineering is not my cup of tea. And in 10th itself, I realized that I never wanted to touch bio again if I could avoid it. So, and back in those days in Maharashtra, it was either you go for engineering or for medical. And I realized by the time I was finishing 12th that I'm not fit for either. And so then somehow I just said, let me take up a BSc and see where it leads, because it bought me a little more time. Well, that's where the journey began, and here is where I am.
So speaking about pursuing a BSc degree, how did you get to know about MTTS and what difference did it make in your life thereafter?
Well, about the difference, I can tell you I'm here because of MTTS. That much is clear. But how did I find out about MTTS is actually a very interesting story. And I think many of us who have gone through MTTS and various programs like this have similar stories. So during my BSc, one of the teachers left after my first semester of first year. And the person who replaced him, I mean, we all fondly call him Dute sir. So Shri B.B. Dute, I mean, he's still a faculty back in Nasik, but not in the same college as where I studied. So he joined the department, and he was a very young, enthusiastic faculty. I think he was maybe just about 8 years older than us. Recently had finished his MSc, was teaching in some other place, I believe in Ahmednagar, not sure. And then he was transferred to our college when this teacher left us. So what we immediately realized is that he cared a lot about students, and also a little bit of credit goes to the head of the department who gave him a free rein. He never interfered in what the Devtesar wanted to do. So sometime in second year, maybe around, I forget exactly when it was, perhaps around December or something. I don't remember exactly, but one day he called 3 or 4 of us to his, well, to the faculty room. There was one faculty room where all the faculty used to sit. And he said, here is a form, fill it, I'm going to send it in. He never told us what it was about. We just filled it and he sent it. And then sometime in, perhaps it was March, I guess, I get a letter saying that I've been selected for something called the Mathematics Training and Talent Search Program. And it's the center is IIT Madras. And I don't think I really knew what the whole thing was all about. But, it was a summer program and they said, you're going to be trained in mathematics for a month and you don't have to worry about food or accommodation. They said they would also pay for the train travel. Well, what else is there in the summer to do? So it was sounded like a good opportunity. And also, while I was selected for the Chennai camp, 3 others from my college, one in my classmate and 2 of our juniors. That time, first year BSc students were taken in. So they were both selected to level O in Goa. So there are 4 of us, and then we found out later on that there were 2 more from Nasik, from a different college, who were also going to go to Goa. So then, it became more like a fun thing to do in the summer. Well, more for them because there was a group of 5 going from Nasik to a different place, but somehow we were all involved in the booking the tickets, this and that, but still never realizing what was actually MTTS. And just to give you an idea as to how unaware we were, the talking point was not the training part of it. The talking point for us was my letter said the program director is somebody named Professor S. Kumaresan. From the name, it was evident that he's from Tamil Nadu, and he is sitting here in Mumbai. And the local coordinator is somebody named S.H. Kulkarni. Once again, from the name, it was evident he's from Maharashtra, and he's sitting there in Chennai. So these were the kind of things that were talking points for us, not what the program was about, because completely unaware of things then. And then once I go there, completely changed what I thought, what I used to know about how mathematics works. One of the first things I realized was when I went to the program is I was very happy about some things because when we talked about sequences, we had Professor Veeramani teaching us about analysis. We were introduced to sequences as functions from natural numbers to real numbers, which we had never thought of it in that way. Well, actually not in the class, but during first year BSc, whenever we talked about sequences, I used to visualize it as a graph. What I did not realize it is I was actually thinking about it as a function from N to R. But the moment he put it in this framework, I realized that what I had been doing was a very natural thing to do. That kind of gave me a good feeling and a very positive attitude towards the entire program. A small sense of what do you say? It's validation of the way I used to think. And then, of course, we had fantastic teachers. Professor Vijay Kodialam was there who taught us combinatorics. Although I think we were more fascinated by his khadi kurtas than, also his course. And K. Srinivas from IMSC taught us number theory. And Professor Sengadir, at that point of time, I think he was in IISc. And these 4 were the main teachers. And then that time, Foundations was not a formal course, or maybe that was the first time it was tried out as a formal course. And so Professor Kumaresan was there the first week. And actually, we didn't know what he was teaching. Now we call it Foundations. We call it the Foundations course, but that's what he was doing then. So it seemed like a big mix of things. And one of the things I recall proving is he asked us some question and trying to prove it. Somewhere along the line, we came across a statement, 1 is greater than 0. And his question was, why? Until that point of time, none of us I don't think had ever thought about that. And, small incidences like this really made a huge difference. Now I'm on the other side of the dais and I've lost count of the number of times I have asked the same question. One more thing I always tell people, in fact, I have my notes somewhere and I showed it to Professor Kumaresan very recently. on one day we talked about finite sets, and he asked us like, how would you define a finite set? And over 20 minutes, he went back and forth with the entire class, each of us trying to contribute something or the other to the definition. And every time we thought we had a reasonable idea, he would point out something or the other. And after about 20 or maybe 30 minutes of discussion, we finally thought we had a definition, which everyone seemed to agree with. And the definition was like, a set is finite if we can find a bijection from an initial segment of natural numbers to that set. Okay? And we had defined initial segment to be 1 to n, or in as we called it. So everyone was happy with the definition until Professor Kumaresan, he threw a spanner in the works and he said, do you want the empty set to be finite or not? So the question was not as important as the fact that it taught us how to deal with things like these. Okay. So it was not the fact that do you want the empty set to be finite or not, but it was the fact that this is how one thinks. We thought we had a very good definition. It's fit everything we wanted, except that it did not fit the empty set. So again, the discussion went on in the class for about 15 minutes when whatever we tried, something or the other broke down. And finally, he said, well, here's how you deal with it. You say a set is finite if it is either empty or it satisfies whatever definition you have. So it taught us something very, very interesting on how things progress in mathematics. And so small things like these, I think we picked up some things we knew but did not know that we knew. So all these things came out during that 1 month. Fantastic teachers, I mean, very good peers. I'm in touch with many of them still today who are in mathematics. And that completely changed the way I think about mathematics. Or, well, actually, I wouldn't say that entirely. To some extent, it changed the way I think, but in a different aspect, it actually validated the way I was thinking about certain things. So I was more confident when I went back to my college that what I was doing was a very natural way of doing things. So much so that I don't know when this transition happened, but my teacher started treating me as an equal. So during my third year BSc, often the way we would discuss with each other, I would discuss with my teachers was more like peers rather than a mentor and a student. And that again boosted my confidence a lot more. And Devte sir used to encourage me every once in a while to go to the board, present an argument. So that helped quite a bit. And then I always used to enjoy sitting with my juniors and talking to them about mathematics, trying to explain to them. Now all that is helping in my teaching. But MTTS, in some sense, the first time, level O, when I went, I think it gave me the confidence that what I was doing, well, I'm not the only person doing it. It is a very natural thing to do because I also met many other people who do something very similar. I also saw things that I had not thought of. So it helped me improve the way I was doing things. And finally, I think on a very practical note, I think what it did was it gave me an introduction to the fact that IITs actually do mathematics. So until then, IITs were these big institutes somewhere out far away. I mean, when you're growing up in a small town like Nasik, I mean, you really don't, even though Mumbai was not very far, I still don't know what IIT Mumbai looked like. So the first IIT I actually saw was IIT Madras. And that was an eye-opener. We saw that many students there are similar to us. And also that IITs have an MSc. So then that kind of set my career goal. I mean, I knew that my next step would be to try to get into IIT Madras, IIT Bombay, because that was closer to me. So, and that time we did not have JAM. So each IIT had an independent entrance. So IIT Bombay, I was trying, and I knew that end of third year BSc, I had 3 options, practically speaking. All 3 were reasonably good: Pune University, Mumbai University, and IIT Bombay. So at that point of time, I got through IIT and I came here. Once again, what is very interesting is this. End of third year BSc, I go to MTTS, and I was again taught by a fantastic group of people. And this was the first time I was introduced to Professor Sayantani from Goa University. And Professor Somasundaram. I had met him the previous year, but this time he actually taught us analysis. And Ambar Habib, who taught us algebra. Okay. Although till date he keeps telling us that he wants to teach analysis, but the first time he came to MTTS, he was always asked to teach algebra, and I think he has been asked to teach algebra many more times. So we were also one of the fortunate batches that level 1 and level 2 we had the same 3 teachers. It's not, I mean, this is not very common, but purely by coincidence, it so happened that topology was taught by Professor Sayantani both years, analysis by Somasundaram both years, and algebra by Ambar both years. So again, very good teachers, and they really helped us think. And by the end of level 1, I think I was so comfortable with things that I don't think I really prepared for the IIT entrance. I don't think I needed to. And yeah, I mean, I did reasonably well in the entrance and got through here. And but the other thing that happened during the MTTS camp was there were 2 teachers from IIT Bombay. One was Professor Jugal Verma, and the other is Professor Akhil Ranjan. So Akhil taught us geometry. Professor Verma did not teach us; he was teaching level 2. But we used to talk to them they were very enthusiastic about going for walks and all that. So we used to go with them, and in the RI Mysore campus. I mean, I think some of you have been to the RI Mysore campus, and it's a very beautiful place. And so they would go on walks in the mornings, evenings, and we would go with them and have lots of chats. And so when I came here as an MSc student, it naturally led me to discuss more with Professor Verma, who eventually became a master's guide. And then it was his recommendation that actually sent me to Kansas. So in some sense, you see that first, of course, it was Divte sir who pushed me towards MTTS, but then MTTS gave me the next link. So I mean, through MTTS, first of all, personally, I had a lot of, gained a lot of confidence in what I was doing. And I also met Professor Verma, who helped me to reach the next step. And our meeting, I mean, that time was purely because of MTTS. And once I came here, I mean, there were many faculty, but I naturally gravitated towards him because we had already met before. And yeah, and then level 2 was a completely different experience, because by then, I mean, I was already confident enough that I would handle things really well. And it was a completely different experience. I think both level 0 and level 1, I went in with a feeling that I was not among the top. I was always looking up to other people. I always thought many people were better than me. But by level 2, I had gained the confidence that if I can push myself enough, I can be as good as any of those. And I think for me, I think attending MTTS for 3 years did make a difference. I mean, each year was necessary for the way my career, the way I think mathematically has progressed. I think each year was necessary for me. And something else that many of you may not be aware of, I don't think any of you are aware of, is that time we had something called a follow-up program. And both after first year and second year, I went for the follow-up programs. It was like a 2-week program in HRI. And there were 1 or 2 week-long, I mean, the 2-week-long courses. And there were many, many talks. HRI has many visitors. Although the first year we went, it was still MRI, Mehta Research Institute. It became HRI the second time I went, in between the 2 times I went there. So they have a lot of visitors, their seminars, and also we used to attend those talks. And there were also these long 2-week long courses, in which what they covered was pretty much like a semester-long course. And so there were just about 10 or 12 of us who were selected from levels 1 and 2, and we were there, and that's all we had to do. And so I mean, in the introduction, you mentioned that I work in commutative algebra, and what you may not believe is the reason I work in commutative algebra is actually because of Professor Kumaresan. So one of the follow-ups, he taught us a course on what is called as Diram cohomology. I don't think at that point of time I really understood what all he was teaching, but there is one small part of it that really stuck to me, and that's what is now, what I now know is known as homological algebra. And that really set my path. So I knew that I was really, really interested in it. I was also interested in algebraic topology, but somehow I gravitated more towards this and eventually ended up in this field. So that, in a very, very big nutshell, is how MTTS has so far impacted the trajectory of my career up to when I started teaching. After I started teaching, I went back to MTTS to teach, and that is a completely different story. So
how is teaching at MTTS different from, say, teaching a course at IIT Bombay?
For me now, there's no difference. But initially there was, because when I was still trying to figure things out, it took me some time to figure out that I can teach the same way as I do in MTTS. The one different thing, of course, is there is a fixed syllabus that you want to try and finish. But the good thing about IIT Bombay is that the syllabus you want to finish is not always very rigid. There is some leeway that an instructor has. Okay, so you want to finish most of the syllabus, but there is still some leeway. But that is not a problem, because I have been been able to do what I need to do and more. The thing to keep in mind, and this is where often the transition from teaching in MTTS to teaching in your own institute comes, is the following. In MTTS, you build things very slowly. You give a lot of examples. You allow students to think. You try the same in your institute. Often the problem is you don't know where to step up your pace. Okay. So even in MTTS, you would notice, I don't know if you've noticed this as a student or not, but the pace that you are going at in the first week and the pace you're going at the fourth week are very different. Okay. You could go at the same pace as the first week, but then that means you're not going to get anywhere. So what happens is, the first week you're going at a certain pace where you want to involve everybody, make everyone think. But then as you go to the second week and the third week and the fourth week, the pace is increasing little by little. You are getting pushed to think more and more. And because of the way you've been trained in the first week, it makes it easier for you to do it in the second week. You think a bit more, then a little bit more in the third week, and then a lot more in the fourth week. Okay. It is also possible that some people reach their ceiling in the second week and struggle in the third and the fourth week. But then they still get a lot more in those 2 weeks than they would have gotten otherwise, because you have pushed them beyond what they thought they could have done. This is the same kind of an approach that one can take here. But the problem, as I said, is often one doesn't know where to push the pace, where to begin picking up the pace. And also trying to compare with what others are doing. For example, one of the courses that I taught, what I did up to the mid-sem is probably what most people would have finished within the first 2-3 weeks. But what I managed to finish after the post-mid-sem is I did a lot more than they would have ended up doing in the course. Okay. And the reason is because you introduce so many examples, you introduce so many things in the beginning that you are setting up the base to push things later. Okay. I know what I'm going to do towards the end. I've already given you the example in the beginning. So the reason I'm so slow in the beginning is because I'm trying to give you a lot of examples which will help you to understand what I'm going to prove in the second half. So it took me some time to figure this out. And invariably, the first time you try to do something like this, you're not going to finish the syllabus. But once or twice, I did this, and once I got comfortable with this, I realized that I could. And so now I think I'm at a point where I don't see a difference in the way I teach in MTTS or here. Part of it is also the flexibility that IIT allows instructors. Instructors have a lot of freedom. So I am able to do the way things I do at MTTS.
So can you share a few non-academic experiences you had at the MTTS camps?
Yes. We found out that our teachers were also human, and they were also very, very witty. And to Professor Jayantan, when he was teaching us metric spaces, I think that was the time when the World Cup was going on. Cricket World Cup was going on. So this was '99 summer, and again, okay, this is a digression from the story I was going to tell you, but let me tell you this also. So all of us wanted to see the cricket matches. What did we do? There were no TVs in the hostels in Mysore. So there was a group of people who found out what to do. There is this engineering college right next door, JC. They contacted some students from the hostels there. They found out some locals. They figured out how to rent a TV. So somehow we got a rental TV on the games, on the days where the matches were. We got a rental TV, we brought it in, fixed an antenna for it somehow again. And we all used to sit there in the hostels watching the matches. But anyway, so the other story I was going to tell you was this. We just went and asked Professor Sayantani. He said, like, suppose we play cricket with an open ball. Do you think it's possible? And those are, I mean, he just got frustrated. He did not know what to answer. But Akhil Ranjan was there. Professor Akhil Ranjan was there. A very, very witty person. The moment he heard this question, without even batting an eyelid, he said, yeah, you can play cricket with an open ball, but I don't think it'll ever reach the boundary. So, small incidences like this, like where we saw the human nature of the teachers, it told us like they are not very different from us students. Someday we'll also be there. So these kind of things were there. And then the interaction with the participants, like, from all over the place, all over the country, you get so many different people, you talk to them, you learn about their cultures. I think one of the, see, for me already it was not a big deal because I was originally from Tamil Nadu, but I was growing up in Nasik in Maharashtra. So already there was like a mixture of cultures that I'd seen. But when the students from Tamil Nadu met me, they were so surprised. They said, oh, you are from Maharashtra, but you speak Tamil. So I realized, like, how people who are growing up in one place and are originally from there, they are not really exposed to a lot of different cultures. And MTTS provided us an opportunity to do this. And I'm trying to think of at least one good incident of this form, but now I can't really remember any such thing. I mean, there are other incidents I know which happened to other people that that are there, but they did not happen to me. So I'll not refrain from talking about it. And I think non-academically, I got some very good friends from MTTS, and they are still friends till today. So in spite of, in fact, as one of them says, when he introduces me to his colleagues, he will tell people that this guy is my friend in spite of being an algebraist. And when I introduce him to my colleagues, I say he's my friend in spite of being an analyst. So that's the kind of things, those are the kind of relations we had back then. And it helped a lot during the research career. I mean, PhD and the journey, even starting from where should I apply for a PhD to how should I go about it. During PhD, you share your frustrations. So all this, it helped. And it started really there. And one other non-academic thing I should tell you is all of you are aware of Professor Srinivasan. I think he may have taught many of you in MTTS. He was doing his PhD when I went for level O. And he was a person in the hostels who, was really helping everyone there. So he's like the junior local coordinator of sorts. I didn't know back then. I mean, I learned it much more recently, but he was actually an MTTS alumni. He was, in fact, one of the, I think he may have been a student in the first batch of MTTS. But talking to him was an eye-opener because here is a person in front of me who's actually doing a PhD in mathematics. Until then, I did not have any idea. The teachers all had their PhDs, but they were still unapproachable at that point of time for us. We thought they were unapproachable. That would change in 4 weeks. But Srinivasan, right on day 1 or day 0, even before classes start, you go and talk to him. And here is a person who's, doing his PhD for maybe 6 or 7 years or something. And then I happened to ask him, says, what do you do in a PhD in mathematics? I mean, I was just like no idea. And in fact, at some point of time, I think I had mentioned it to my friends, maybe in 11th or 12th, or maybe first year BSc sometime. somebody asked me what do you want to do? I said, I want to do a PhD in mathematics. They all started laughing because none of us actually had any idea. And then I asked Srinivasan, what do you really do? He says, I have no idea. The day I think I get an answer, I'll get my PhD. And the number of times I have used that answer, I mean, is, yeah, I mean, I've lost count of it. And so he's one of very good friends of mine. And I think MTTS is too. I should thank MTTS for it. Like initially was a mentor of sorts, now very good friend. So.
Well, you mentioned about your PhD. Can you tell us a little bit about your time in US?
Yeah. So see, when I was finishing my MSc, I had this idea that we should stay in the country, do a work here only, not go abroad. So it was the kind of thought process that I had. I mean, along with a few others of friends of mine. And then after MSc, actually, I did not go to the US directly. I spent a year in TIFR, and so in TIFR also I had a mentor. His name is Professor Ravi Rao, and I mean he in fact, as I mentioned Professor Verma earlier, Ravi Rao and Professor and Jugal Verma, they are both still in some sense mentors to me. Like, I still keep talking to them about various things, and they have never stopped mentoring me. So in talking to him, I realized that it's the kind of reasons that we were giving as to why one should not go abroad and all that. Eventually, in talking to him, what I realized is I could actually accomplish whatever I want to, even if I do go, as long as I come back. So kind of set in motion. So first year, I was constantly talking to him. And so the thing in TIFR was at the end of the first year, there's an interview. And one never knows what happens, right? I mean, you can get through, but on the other hand, you may not. So one really doesn't know. So just to keep my options open, I mean, in case something, in case I don't get through, in case something bad happens, I just thought maybe I should have some backup options. And so I used to discuss this with him, and he also encouraged me along those lines. And then he said, yeah, okay, fine, let me maybe apply for a PhD to the US. But I did not have the idea, even though I was applying, it was not with the idea that I will go. So once I, again, it was each application used to cost like some $60 or $90. It was expensive. So I was very clear that I was not going to apply to more than 4 places. So I used to discuss with him where to apply, what to apply. And so he would ask me, what do you think you can get in your GRE? If you can get this much score, then we can apply here. If you get this score, if you think you can get this score, then we can apply here. So in talking to him, kind of decided on 4 universities, none of which was Kansas though. That was the interesting point there. And once I decided that I am going to apply to 4 universities, I came here to IIT to talk to JKV for letter of recommendations. He had already asked me the year before when I was finishing my MSc. He said, if you want to go abroad, people in Kansas are looking for students. I can recommend you there. But that time, I mean, I had not written GRE or anything, and I was not really wanting to go. So I had said, no. This year when I came back, he said, you should apply to Kansas. Huneke is there. Again, I think this probably goes on to say how unaware I was. At that point of time, I don't think I really knew who Huneke was. I mean, I had seen some of his works, but I don't think I realized exactly this is the same person that Jugal Verma was talking about. And so I just searched on Google. I said, okay, Kansas, Huneke, and I saw it led to me a certain university. And the best thing about it was their application. The US university's application forms are like 40 pages long, and you have to fill in so many pages of stuff. And here was one university where their application form was 1 page front and back, no deadline, no application fees. I said, why not apply? So I just applied. And what was very interesting is by the time I got the letter from them, it kind of said that Honeke would be very, very interested in taking me as a student. He didn't say it that explicitly, but there was enough in the letter to say something of that sort. Okay. In fact, I recently found that letter in my old stuff. That yeah, I think about 20 years ago. In fact, 20. So yeah. So then what happened was I actually got 2 offers. One was from Purdue, and the other was from Kansas. The Kansas letter was more or less, it said that Honeke will take you as a student, kind of a thing, provided I cross some bars. Purdue, I had received about a month before I got Kansas, and I thought about where I was. I was already in TIFR. I had been talking to people, and I realized that if I go to Purdue, I mean, I don't have an advisor lined up. I mean, I don't know the people there, so I would have to go there and again do all the initial coursework, talk to people, figure out who an advisor. Whereas I already had been doing that in TIFR. So I even though Purdue was highly ranked, the way I was thinking at that point of time, I thought that I was better in TIFR than going abroad to a completely new place and trying to start all over again. But then this letter came about a month later in March from Kansas, and it kind of indicated that Honeke is interested. So once that came in, I again, as I talked to Ravi Rao and JKV, and they were both of the opinion that this is a golden opportunity because Honeke is a fantastic teacher. So based on what I had heard from them, and so I just said, fine, I'll take it up, and I decided to apply to Kansas, and or rather, I decided to take up accept the offer, and I went there, and my experience was very, very interesting. I mean, again, what I never realized until I actually went there and started talking to Honeke is how big a shot he was. Very, very well known. I mean, extremely respected in the commutative algebra community, and a fantastic teacher. But as a person, when you talk to him, you'll never feel any of this. So, in fact, one of the other teachers in Kansas once told me, he says, Honeke puts in a lot of effort to make you feel not nervous. So small tip like this, which teaches you certain things. Like now I realize when I'm on the other side of the dais that students are often nervous. So one has to make an effort to make oneself approachable to the students. This I've learned from Honeke. And in fact, the first day I met him, I mean, I walked into his office. He was sitting there with some other student playing some board game. And this was a common feature. Apparently, I did not know then. But over the next 7 years that I was there, I used to see this every day. I mean, he had this half-an-hour block where he would play some board game or the other with some student or the other. And I have myself seen over 7 years, maybe 4 or 5 different games. And it often depended on where the student was from, and different people from different countries. He would try to pick up some of their games and then play with them. So it was very interesting. Again, a very, very renowned researcher, but at the same time, he never gave up on simple things that one does. So again, you saw a human nature to it. And I realized that, to be in research, I mean, one doesn't have to give up everything else. In fact, I always think that you should have other things you do because it helps you deal with the frustrations you encounter in research. And the one thing I realized, which I don't know how things are now in India, but back then somehow the impression always was when you're doing research, when you're doing PhD, that's all you should do. In some sense, many advisors expected you not to have a life beyond your PhD. But this was very different out there. Everybody has a life. They work for a certain amount of time. Beyond that, you have a life. So this I saw, like right in front of me, my advisor himself. For him, his family always came first. In spite of that, in spite of the fact that he was very, very rigid about the way he would schedule things, family always came first. I mean, he and his wife both were faculty members, so they would split the kids' duties between them. So one of them would be there in the mornings, the other would be working in the afternoons. So when they were working, they were purely working and completely focused on this. When they were with the family, they were with the family. So it's taught me, like, things like compartmentalizing your personal life versus your professional life without compromising either. And he was very good at it. And I think, I don't think he has ever spoken about it. I think I've just learned by observing. And so these, I mean, so far I've not touched the mathematical aspects. Okay, so, and this is only about Huneke. But then there are also other faculty there with whom I had a lot of interaction. Professor Purnam Pragya is one such. I mean, he, again, he knew, I knew of him because some of his teachers were still there in TIFR. And Professor Ravi Rao had told me that such and such person is there, you should go and talk to him. So I started talking to him, and for 3 years we had different kinds of reading courses. So I used to read some stuff and present it to him, and with other students, and we would just present it to him. And I learned a lot from doing this. Mathematically, I saw how, especially teaching, what I noticed was, again, with Huneke, I saw that. So again, here is something I had noticed when I was a student in India. I had encountered two kinds of teachers. One was those who would write everything on the board, and you would copy down the notes, go back, read the notes, and try to understand what had happened and all that. And they would write a lot. You would have no time to think in the class along with them. There were others who would make you think a lot in the class, but then you were not allowed to write. So you had to be really focused so that after you go back from the class, you could write down and recall everything that happened and write it down. And I mean, of course, this it would help when you discussed with the others, because then with everybody you could kind of compile the entire set of notes. With Huneke, what was very interesting was he would allow you to think in the class. He would give you lots of time to think. But and he would write things on the board also, and you could write down the notes. And when you went back and saw, you also would notice that he had covered a substantial amount of material. And I have no idea still till today how he does that. So in his class, you had fantastic notes. You were able to think along with him and also cover a substantial amount of material. Okay. I really admired that, and I don't think I still know how he did it. And well, hopefully before I retire, I'll be able to figure it out. So other than that, what I also learned, as I had mentioned earlier, is people have a life outside of their own PhD. So almost every semester, I used to try to do something different. I always made it a point to interact with the Indian students community there. I used to talk to a lot of people. I also made a point to interact with people who are not Indians, because before I went abroad, one of my friends told me, see, by the time you come back, your only friends there would be Indians. You'll never, ever talk to anybody else. So I wanted to prove him wrong. And so I made it a point to also like interact with a lot of other people, learn about their cultures. And the diversity in the PhD program itself helped. So I met a lot of different people from lots of different cultures and different countries, talked to them, learned a lot, helped in. So what I told you earlier about, how in MTTS we meet a lot of different people from different parts of India, helps you to understand different kinds of things. There it was happening at a much larger scale. And I was a teaching assistant right from day one. That was really good experience, because now, even though I have been a faculty in India for 10 years, I have actually been teaching formally for 20 years and informally for about 25 years. So that really, really helped. And the teaching evaluations that one would get interacting with so there would be mentors for us, the faculty members who would mentor us when we were teaching. So interacting with them, getting small tips on how to improve our teaching, what should one focus on. These kinds of things really helped. And it just took off when I came to MTTS, of course, because then I was now free to experiment a lot. So, but when I came to MTTS and started teaching MTTS, I already had a lot of ideas on what to do and what not to do because of this teaching experience. Yeah, and yeah, as I said, yeah, almost every semester I used to try something new, completely different from anything in academics, like various hobbies you pick up and so on and so forth. So I think overall it was a very good experience. I would not give it up for anything. On the other hand, I was also very clear that it cannot continue. So again, my two mentors here in the algebra community, Professor Verma and Ravi Rao, I talked to them. During my visits, I would keep talking to them about what is happening. So I talked to them, I told them that I do want to come back. And both of them said the same thing. Said, make sure after your PhD, you finish a postdoc and come back. But what is very interesting is the reasons they told me. Both very practical reasons, but both very different perspectives. What Professor Verma told me is, he said, see, good institutes in India require you to have 3 years of experience after your PhD. It allows you to get time. It allows you time to get good publications. So you're in a much better position when you're applying. That was his advice to me. Professor Ravi Rao, he said the same thing. He said you spend 3 years as a postdoc and then you come back to India if that's what you really want. His reasoning, other than this one that Professor Verma had mentioned, was also another angle from which many of us don't really think when we are in a PhD. Somehow we have this altruistic thinking that when we are doing this, it's some kind of a big self-sacrifice you're doing and you should forget everything else. But no matter what career path you choose, you should keep in mind that at the end of the day, you should earn enough to have a reasonable life. And I'm not saying that you should be minting money, but you should at least have enough money in your bank account to be able to lead a reasonable life. Because when you don't have to think about those aspects, you can actually focus on the other things you really want to do. Now, if I was struggling to make a living, I don't think I can contribute to the teaching activities that I do. So his advice was very simple. He said, as a postdoc, you earn a lot more than you did as a student, but your spending is probably going to be the same, which means that by the time you come back to India, you have a reasonable bank balance when you start your job, which is not true for everyone. So that safety net will allow you to do a lot of things. That was a fantastic piece of advice. So both of them said the same thing, finish a postdoc and then come back. But the perspectives they offered were very different and both very true. So very necessary. And so yeah, so that was the story behind the US trips, the postdoc, and eventually, coming back to India.
Like, so coming to the challenges, what challenges did you face while you were doing your PhD, and how did you overcome them?
See, I think one of the biggest challenges everyone faces, I think, during a PhD is you are going to be frustrated. Anything you try, everything you try is going to fail at some point of time. Okay? So it's like, when I used to talk to my juniors in Kansas, I used to tell them this, like the 3rd year, 4th year syndrome. You are stuck. You don't know what to do. And because you are so focused on your problem and your lab or your own work or whatever, you are not talking to others about it. What you don't realize is so is everybody else. Okay, so this is something I also faced. I was stuck. I did not know what to do, and the only thing to do was just keep persevering, keep doing it. And as I said, it did help to do other things. Because when you're constantly thought about something and it doesn't work, just stop thinking about it. Do something else. Your mind will, throw away the unnecessary things and often will allow you to focus on what really was key. So, I don't have a story like, Kekule's story of 6 monkeys holding hands or anything and solving a theorem or anything of that sort, but it has happened. You're doing something completely random and suddenly some solution appears somewhere. This kind of things happen. And but it's not like inspiration or like somebody putting the thought in your head or anything like that. It's because you've thought about it long enough, and now when you're not actively thinking about it, there is some thought process going on in the mind, and when you're just doing something else, the right idea just comes out. So this has happened, and doing various other activities other than what I was doing really made a difference. I think that was the biggest, I think, challenge is figuring out how to overcome these kind of frustrations. The other challenge, of course, was you're especially when you go to the US, you're in a new place, new culture, new everything. But I think somehow maybe this is also my attitude where I don't really I never really thought of it as a challenge. I always thought of it as a new opportunity. So for me, every time something like this happened, I mean, I would treat it as an opportunity to learn something new, and so it did not really become a challenge of sorts. So and also I had very good advice from different friends. Like before I went to the US, I was talking to somebody and I asked him this question: what would happen? What should I expect? What would I see? He said something very interesting, and he said, see, you will find people there. They have one head, two hands, two legs, just like you and me. They may talk slightly differently, but that's about it. They may not understand what you're speaking. That's fine. But eventually you'll start understanding each other. So don't think too much. And this kind of advice really helped. So, and also one challenge, I mean, one thing that was difficult, I guess, was actually one particular thing about this frustration that I mentioned. Academically also, there was something very interesting, and this was Honeke encouraging me. When I was stuck on my problem and did not know what to do, he said, well, stop working on it, pick something else. So over the next couple of months, I just randomly searched for different papers that I thought may interest me, that fit the background I already had. And I found a 3-page paper of my current colleague, Tony. And I read it because, well, stuff was familiar to me, but more importantly, I read it because it was 3 pages. I thought I could read it. And by that time, I think I was fresh enough to start working on my problem, and I kept it aside. Later on, it so happened that I used this again to deal with another frustration of sorts. So end of sixth year, I was thinking, I mean, Honeke had said that I had done enough work to graduate. So 5.5 years, I started applying for postdocs and whatnot, and got nothing. So I must have applied to a lot of different places, but I got absolutely nothing. But he had a backup plan. He told me that I could continue there, and he was ready to fund me and whatnot. So that really made a big difference. So I knew that I had a backup option. So end of 6 years, I don't, so this was a very frustrating time. Don't have, you're applying for a lot of positions, you're not getting anything. But because of this, I fortunate to have an advisor like him. There was a backup option, so it was not really too bad. Okay? I knew at the back of my mind that if nothing else works, I have this option. And so then next year, that summer, say end of 6 years, he said, well, we anyway had thought that you have finished your work. So if you want, stop working on that problem and pick up something new. And next year you can work on something completely different. I went back to the 3-page paper of Tony's, and we actually worked on it, and we got some new results in that direction. And so, yeah. So now if you look at my thesis, it's actually 2 problems. One was what I was originally working on. Second is this part. But this really came out of, because at some point of time, I did not know what to do with my problem. I was completely frustrated. So I just picked up something and started reading it. And this is what came out of it. And it is still paying dividends. In fact, some stuff written up here is related to that paper. So yeah, I don't know how satisfying an answer this was. But part of it, I think, is because I'm not really sure I think of anything as a challenge. I always think of it as an opportunity. So, and that's how things have always been. And I've always been fortunate, I think, to have some kind of backup plan or the other. So it never has been like a frustrating scenario. so much so that I did not know what to do. So yeah, I don't know if that answers the question that you originally asked or not, but that's what I have to say.
Okay. So we'll take a small break and go into a rapid fire round where there will be like short answers.
Oh, you
So,
want me not to speak so much?
No, we want you to speak, but there are more questions.
Yeah, go for it.
Sayantani, will you begin?
Yeah, you start.
Okay, so do you ever feel that you don't understand math?
Always, all the time. If I understood it, I think I would give this up and go somewhere else.
Okay. Do you occasionally get impressed by other mathematicians?
Yeah, all the time. I think I can learn something from everyone. So, sometimes it could be what not to do, but you can always learn something or the other from everyone.
Which course do or did you enjoy teaching the most?
That's a tough one to answer. I think the one that I usually find most interesting is the course that I'm teaching for the first time, because then I have to think a lot to figure out how to put it across to the students. The second time I teach it, because I've taught it once before, I already have an idea about where students get stuck and all. So I think any course that I'm teaching for the first time, I think it's always a big challenge and actually very enjoyable.
Okay. What is your favorite thing to do on the IIT Bombay campus other than mathematics?
Teach. Okay, teach comes under mathematics, right?
Yes.
Okay. So I think the most favorite thing to do ever anywhere is sleep. So, but now, I think for the last couple of years, I think the most favorite thing to do is spend time with my daughter.
What is your favorite book?
See, now I feel like it's a proper interview. Not really sure, but my favorite books are all in the realm of fiction. I don't. I prefer not to read books that make me think too much, because my job involves a lot of thinking. So when I read other books, I prefer to read things that don't make me think too much. Okay, so if you ask me for my favorite writer, I think I would like to. More than favorite, it's about who has had a big influence on me. It's Agatha Christie, and mainly Poirot. So his love for symmetry and logic and whatnot has had a huge impression on me from a very long time.
Okay. Which fictional character do you think is most likely to end up as a mathematician?
Poirot. Again, because of his love for logic and whatnot.
So last question for this round. We have heard that you like to write. Can you recite 2 lines from your favorite composition?
I don't have a favorite composition. Yeah. In fact, you just want a couple of lines?
Yeah.
Yeah, anything.
Or more than that?
Anything you prefer.
So give me just a second, and I will answer that. I have written a lot. I just don't share it all the time, but I have written a lot. So I don't really know what would be my favorite, but so yeah, I think See, this is not necessarily my favorite, but I think it kind of tells you why I write. So it's yeah. So some days you feel like Atlas shouldering the earth is standing on your head. Overwhelming days with a dearth of mirth, filled with an unknown dread. There are other days when the sun shines bright, a spring in the step when the heart feels light. On such days, in case you don't know what to do, just write.
Wow. We would like to read and hear more of that.
Yeah. So yeah. Anyway, there's more to it, but I think this part, it's. I think I once wrote why I like to write, and this was what it was.
It's beautiful. Coming back to our original set of questions. Once you asked someone, what do people do in PhD? We want to ask you, what do algebraists do?
What do algebraists do? I think try to make everything very formal. Anyway, that's jokes apart. But I think if you see what algebra does is it tries to extract out abstract things as much as possible in some sense. So I'll specifically talk about commutative algebra just to give you these examples. Like, in algebraic geometry, you deal with zero sets of polynomials and all that. And in number theory, you deal with, factorization and all that. And this happened a long time ago. But this is an example of what algebra does and what algebras do. You observe something common in both. Okay? There are some rings somewhere, and then what you're talking about is some ideals and the way they factor or the way they decompose and whatnot. So this, I think, in some sense, is like the essence of algebra. So you try to extract out and try to abstract out what is the reason behind something happening. And in the process, of course, you lose the visualization, the geometry of the actual objects that you're dealing with. Often you lose them. But that's the nature of what it is. It's very, very abstract. Things are being made slightly formal. I will not, there is a belief that algebra is very dry, too formal, but that I think is probably because of the way it is often taught. It's taught like a bunch of, axioms followed by very abstract examples and whatnot. If you actually come up with the concrete examples where it all came from, then it is not so dry. So, yeah, I'm not sure what else to say about this.
How do you choose a problem to work on?
You mean now or during your PhD?
Like now or
See, no, the answer is different because during your PhD, very often, that's what the guide is there for. Because you really don't know, okay, when you're looking for a problem, the things to keep in mind is you don't want it to be solved in 2 lines. At the same time, you don't want it to be so difficult that nobody can solve it. At the same time, you don't want it to be something that 50 other people are working on at the same time and somebody else solves it before you. So in other words, you should have a feel for the problem as to, you can't predict that how difficult it's going to be or how easy it's going to be. But at least off the bat, just looking at it, you should not be able to say, oh, I can solve it in 2 days. Or I can never solve it. Okay? So you should have some feel for how to tackle the problem. You should be aware of who are the other people working in this, what is the current state of affairs. And this is where, as a student, you're not aware of all of these. So that's where the guide comes in. So often the guide's job is to indicate all these kinds of things. Now, when you are the guide, how do you come up with problems? It's essentially like, you read papers. Often what happens is in papers, things are posed as questions. Okay. They are ready-made problems for you. So that you can pick up. Or when you are reading some papers, you see something happening. And then this is, in fact, the way we do our exploration. That's more or less how we do it. You read a paper, you start thinking about what works, what doesn't work, why is it working, where else will it work? See, when somebody writes a paper, they have one specific problem in mind which they're trying to answer, and they'll do it. They are not necessarily thinking about all possible offshoots. But when you are trying to understand what somebody else has written, when you're just trying to explore, there are many other things that can come in. But this is when we are talking about theoretical fields. If you're talking about applied fields, somebody else is giving the problem to you. If you're working with an industry, the industry says, here is a problem. How do you solve it? That is different from what I just described. So this is more theoretical, where you have more freedom to explore on what kind of problems you want to solve. At the end of the day, you still want to connect it to the existing problems, existing literature. How does it connect to what is happening, so that others are interested? Okay. Otherwise, nobody is interested in what you've solved. Then, well, yeah, I mean, you want people to be interested in what you're solving. So, since I work in a theoretical field, I mean, this is how I go about it. Just to give you one example, I mean, recently a student was reading a paper and presented it, and then while presenting it, there was some notation that we were not very happy about. So we thought how to improve the notation. That's it. But while doing that, we realized that this could actually work more generally. And so while reading the paper, it was not to, start working on a new problem. It was just to read the paper, understand what's going on, because it was very interesting. But then something just came out of it. So yeah, I mean, it is like, to quote Ollivander, it is not the mathematician who chooses the problem, it's the problem that chooses the mathematician. I don't know.
Okay. We had a question from Elancheranda, and I'm going to ask it. There are a plethora of research articles available for independent study. In this context, can a person do mathematical research by themselves?
Yes, definitely. But the thing is, I mean, where you need guidance is the three things I mentioned earlier. You can work on I mean, the question would be, what is your goal? If your goal is to publish, then you should think about this as to how easy is the problem. I mean, it should not be too easy, not too difficult, I mean, not impossible. And at the same time, you would like to be the first to solve it. If your goal is to just to understand the nature of the problem, then yeah, you can just do it. Then there's no question of publishing. It doesn't matter whether it's easy or difficult, or somebody else solves it first. So with the availability of this, yeah. But at the end of the day, what do you want? Do you want other people to recognize your work? For that, I mean, often what one needs is people should, either the work should be so phenomenal that they don't care about where you came from. If not, why is it important to be associated to some place or the other? Because that already opens some doors. Okay. So if you are a member of some institute, then at least the people in that institute will listen to you when you say, I have proved this. The problem also is this plethora of information that's out there. How do you know whom to read? So if you are an independent researcher who has no connections, when I have so many things in front of me, why would I read your paper? Or why would I read what you have written? So again, this is what I meant by saying, what is your goal? If your goal is to just do the mathematics and not worry about who's reading, who's not reading, and whatnot, then yeah, you can do it. But if you're the next step, if you want to take the next step and you say, okay, I would like this to be presented to other people should see it, then you need to have a circle of influence. And for that, you may need the crutch of an institution. You may not be able to do it on your own. So.
You mentioned earlier that doing a PhD should not mean giving up everything. Like, how do you maintain a work-life balance, and what was lockdown like?
See, my daughter was born in July 2020, so there was no lockdown. So I mean, because of her, I don't think we actually had time to contemplate lockdown or anything. So extremely busy. And so the first year of COVID was that, and second year of COVID was trying to recover from COVID. So it's lockdown was really not. It didn't impact me the same way as it did many of the others. Also, there's something very interesting that lockdown taught us. I think you may appreciate this example. in lockdown, I mean, I don't know if you noticed, but you were as far away from the person in your neighboring building as you were from the person in a city 1,000 kilometers away, and you were equally far away from a person who is in, say, National University of Singapore. That is discrete metric. So one thing that the lockdown actually taught us was discrete metric is there in real life. So anyway, that was a digression. But so what do I do in to maintain this work-life balance is I do the work and I let my wife maintain the life balance there. So anyway, jokes apart, it's I try to make it a point that not to take work home. During lockdown, that was not possible. So the times that I would work, that would be meetings. I think there were some fixed times that I would be there. There would be certain times when I would decline anything, especially after my daughter was born. So, like for example, even now, evenings I try to keep it free. I try my best to not schedule anything in the evenings. I want to make it a point to be at home as far as possible, and always have some activity or the other. Like I make sure that when I go on a trip with my family, I'm not going to answer emails. I mean, I tell people that I'm on a break. I'll get back to you after I come back. Sometimes it's difficult because everybody's so connected, especially in the last 2 years. But I try to do that as far as possible. So, in fact, when I initially joined, I used to try this. I said, I'll not respond to any emails between, like some 8 p.m. and 8 a.m. or something like that. But I don't think that was, I could stick to that for too long. But so I mean, some things keep changing. You also keep changing things on how you deal with it. When I was a PhD student, I mean, I was very clear. Each semester, I tried to do something very different. Outside the department, I mean, I used to interact with people that are nowhere connected to anything else in my life.
So our next question is, can you share the experience of guiding an aspiring math student versus being one yourself?
I don't know if there's a difference. Okay, I mean, there is a difference, but in the sense that, okay, see, when I was a student, I mean, what I'm doing with the students I'm guiding is pretty much how I was learning things. So often, I would put myself in a position where I as if I don't know where they are going, and then ask questions. So every time a student would tell me something, I'll just ask questions. And this question is not because I want to lead them in some direction. I ask that question because that's someone that naturally would come to me if I was at that stage. Of course, the reason I said there's a subtle difference is because now I know where things can go. So often I'll try to give some direction to the questioning, but very often I try and see if I can avoid it. So then it's probably the same thing. One can say I pretend as if I don't know the answer to the question I'm asking, but oftentimes it's not just pretense. I mean, oftentimes it's just that I had not thought about that question before. So when you are presenting something, when a student is presenting something to me, the question just occurred to me now. So I ask it. And so in some sense, not much of a difference. If at all there's a difference, it's in the fact that because I know more, sometimes I know what to expect, what not to expect. And maybe I kind of maybe guide the questions in a certain direction. But beyond that, no, not much.
What are some myths students have about doing research in mathematics?
Well, what are some
Myths.
myths? First myth I think is that you can suddenly get an inspiration. That's see, you can get an inspiration provided you actually thought about the problem for long enough. Okay. Then you can call it an inspiration if you've not thought about it for some time, and then you're doing something else and it suddenly strikes you. But if you believe that Somebody gave you a problem and you never think about it, and you sit under a tree and suddenly Ramanujan will come in your dreams and tell you what the answer is. No, that's not going to happen. So I think that's one of the biggest myths. I think you have to put in a certain amount of effort. After that, yeah, inspiration may strike you, but that probably is because you already thought about it long enough somewhere along the line. That's one. I think the biggest myth. It's not just about mathematics. I think it's about research in general. Yeah, I think that's the biggest thing I can think of the top of my head.
So, when you decided to pursue a PhD, did you face any societal pressures because you did not want to pursue a regular job?
Actually, this thing happened at the end of 12th standard itself. And very fortunately, I did not face it. So in the sense that my parents kept me insulated. So the day I joined BSc, in fact, the day my 12th results were declared, the next day I went to my college, I said, I'm joining BSc. And many people were shocked because, as I said, that time in Maharashtra, it was either you go for engineering or you go for medical. And then why would somebody who seemed bright enough want to join a BSc is a question that everyone asked. And the thing was, I did not get a lot of questions about this because they were all directed towards my parents. I had no idea about it at that point of time. But there was still enough questions to me, and what I used to do was, frankly, there were about 10, 15 different reasons as to why I chose a BSc over other things. And not everybody would know all the reasons. And here is where I also learned that if you give somebody the wrong reason, they'll never be convinced. So even though I had 10, 15 reasons, depending on who asked me, I would just give them the reason that they wanted to hear, that would satisfy them. And well, it kept me off my back for some time. Then I think one of my favorite answers, especially among the group that was infatuated with IITs, would be like, I want to join BSc just so that I can prepare for JEE and write it again next year. That was somewhere at the back of my mind, but I never thought that it was really. I was very serious about it. But it was there was a group for whom this reason was so satisfying that they never asked me anything again. But mostly, I think my parents faced a lot of it, and they kept me insulated from it. They never allowed it to reach me. And I found out about it only after BSc. So once I finished BSc and I was going to join IIT for MSc, then my father just took me to his office because all of a sudden many people wanted to meet me. So he took me to his office, and after meeting everybody, talking to each person, he would point to them and say, "This is what they said when you joined BSc after 12th." And that's when I realized how much they had insulated me. So I think for that, they deserve all the credit. I mean, it never came to me. So all the societal pressure back then during BSc itself was handled by them. It never reached me. And after that, I mean, I don't think, barring few questions like my after MSc when I joined PhD, when I joined TIFR as a research scholar, my barber asked me, "Aur kitne din padhne wale ho?" So then I had to explain to him, I'm now actually getting paid to study. And by the time that year was over, Abdul Kalam had become the president. Then he would ask me, "Oh, Abdul Kalam jaise kar rahe ho kya?" I said, "Yeah." So by then, I think the perspective had changed slightly. So yeah, I mean, so I did not face too much of the pressure as such. People did ask questions, but I think the brunt of it was handled by my parents. And this was not while going for a PhD. It was actually much before that.
So a lot of students get scared even hearing the name of maths. So what are your views on it?
I'm not really sure. I mean, okay, if you ask me how to change it, I really don't know. I really don't know if we can change it, because I think it's just too ingrained in the heads. I mean, I think all we can do is there will always be people who are afraid of maths. there are also enough people who are afraid of physics and chemistry and whatnot, but it's just that physics and chemistry don't show up right from first standard in school. So part of it is also like it's, I call it the Times Square syndrome. I don't know if you've heard of this thing called Times Square in New York. I've been there. It's a place with lots of lights and lots of people, and I never understood what the hype was about. But because each person who goes there says, "Oh, I've been to Times Square," everybody wants to go there. So I think it's like a self-propagating myth. Everybody says, "Oh, I'm afraid of mathematics." So a small child comes across, they feel that that's a normal thing to do. They become afraid of mathematics. So I think it's just a self-propagating kind of a thing. Part of it is also like the teaching also plays a role there. The parents also play a role there. I think every time you say in front of a kid that mathematics is difficult, of course it's going to be difficult. So I'm not sure what one can do about it. I think the only thing we can try to do is when you interact with somebody, you try to show them how easy it is. I mean, not easy it is, but at least that it's not as difficult as that they should be afraid of it. But when are you going to interact at that level and with how many people? So, yeah.
Last question for you today is, could you please give some advice to aspiring mathematics students?
So I think the one thing I will say is there are many points you're going to get frustrated, but it's fine. I mean, but just keep working at it. And at some point of time, you may feel like, maths is not for you. That's also fine. Keep at it. If you succeed, very good. If not, don't worry, because there are many things you are good at. Like each of us, there are many things we are good at. It's not like, you're only destined to be this or that or that. You choose one career, you'll be good at it. But yeah, I mean, as an aspiring math student, I mean, keep at it. But at some point of time, if you think that you should maybe do something else, do it. It's not, there are many people who will say, oh, you wasted this time, you wasted that time. You never wasted any time. All the time that you spent learning the mathematics, you've actually learned a lot. It's also applicable in many other places. So my first advice is keep at it, but don't keep at it, until you completely break your head. At some point of time, you should realize you can go to something else, and that's also okay. So it's not just something for aspiring mathematics students, but it's for all students. I think it's you're not good at only one thing. You're good at many things. Sometimes some things don't work out. That's fine. You should be aware of all that you're good at. In fact, the thing that I always tell the students is be aware of what you're not good at, or be aware of the things that you don't want to do. Pick up things in the complement, you'll figure out what to do. So yeah, maybe not again a very satisfactory answer because it's not necessarily for an aspiring mathematics student, but that's what I would tell all students.
Thank you so much, sir, for joining with us today and answering so many of the queries. I'm sure all of us have been inspired from whatever you said, and you have got some great advice. We want to thank you once again for giving us your precious time. Thank you.
Thank you so much.
If you want to say any last words, you can go ahead.
It's just that, I mean, this I mentioned to Priyanka when she asked me, that if I would interact with you guys, it's, I think by, from whatever I said, it may appear as if I've already reached somewhere, but no, I think I have a very long way to go. Whatever I've tried to share with you is what has brought me here. I still don't know what all I'll have to do to go wherever I end up. So I still have a very long way to go, and let's hope that at some point of time I'm able to say a lot more than what I've just said, and I've had enough experiences that I can share with you guys sometime in the future also. But as of right now, I mean, I'm still a very long way to go. I'm still beginning things here.